Okay, so today we're going to cover section 5, and today we're going to transform the functions, the graphs of the functions. So when we transform graphs or functions, what we're doing is shifting our graph. We're going to be shifting it vertically, which means we're going to be shifting it up and down. We'll be shifting it horizontally, which means left and right. And then we'll also be stretching and shrinking and reflecting the graph. Keep in mind that when we apply these rules for shifts, they wouldn't be as accurate as if we were to do a function table, plug in a bunch of x values, and evaluate it that way. But the 3 main points that we're going to get from the parent, those points should be accurate. So the next slide has the rules for the vertical shifts. Again, a vertical shift is a movement up and down. So when there is a number being added to your function, whether it's an absolute value function, a square function, or a square root or a cube root, when there is a number being added to it, it's not going to be in any kind of grouping symbols or parentheses. When it's being added, it's going to be a vertical shift up. If it's being subtracted to your function, then that will be a vertical shift down. So here, for example, if I have an x squared function, there would be a number that's being added to the x squared, and this would tell me that I would move it 4 spaces up. If it's being subtracted to a function, let's say it's x cubed, then this would be a vertical shift 2 units down. So that's what we do here when we shift it up and down. Now we're going to apply these rules and do 2 examples. Now I notice both problems 1 and 2 are the same, so I'm going to add a plus sign to number 1 to make it a different function. This was a typo. There should be a plus sign. The first thing you're going to do is you're going to take a look at the type of graph we're supposed to be making here. I'm supposed to be graphing a parabola. This is the x squared graph. This is the parent function that I'm going to refer to. So yesterday we saw, and I'm going to just name this g of x so it just has a different letter to show that this is a different function. I'm going to do my table and get my 3 points. I'm always going to be plugging in -1, 0, and 1, unless it's the square root function, because I don't want -1. But I'm going to plug in these 3 numbers into the parent. Most of them are the same order pairs, but if you forget, you can quickly do it. -1 squared is +1. 0 squared is 0. 1 squared is 1. These become the order pairs that you're going to graph for your parent. So I'm going to graph 0, 0, -1, +1, and then +1, +1. You need to memorize that the parabola takes on the shape of a U. Now, instead of getting a table and plugging in different numbers into this, all we're going to do is apply the shifts. You need to memorize that when there is a number added to your function, this means I'm going to take these 3 points that I just graphed up 2 units. So I'm going to take the 3 dots that I just put on here and move them individually. So I'm going to move this one first. 1, 2, put a point right there. Then I'm going to take the 0, 0, move it up 2 points or 2 spaces. And then also the 1, 1, move it up 2 spaces. I've now just graphed the x squared plus 2 by using the parent and just moving those 3 points 2 units up. So this one, I'm now going to move this 2 down. So again, I'm going to graph the original parent, the -1, +1, the 0, 0, and the 1, 1. And now I take each one of the points and move them down 2 units. So this would be this graph. the original parent, and then the new shifted. If you don't want to connect the dots for the parent, that's fine, but I would at least get those 3 points on there so you have a visual to move them. Next, we're going to shifting our graphs left and right. Now, this one's a little different. What's going to happen is the number is going to be in a grouping symbol. It's either going to be in the absolute value bars or it'll be in a parentheses. So the previous example, it was x squared plus 2, and this meant up to. But now what'll happen, it's going to be in a parentheses, so it'll be like a binomial squared. And then when it's plus a number, it's backwards of what you would think. So this would be 2 units to the left. So somebody once told me that think of the grouping symbols as this number's in jail and you wouldn't trust the person in jail. If the person told you to move right, you're really going to move left. And then if there's somebody on the outside of jail and they tell you to move right, you listen to them. Whatever it's going to take to help you remember. So if it's in the parentheses, it's backwards of what you would think. You would be thinking you're moving to the positive side of the graph, but we're really moving to the left side, which is where the negatives are. So let's try this. So if it's adding a number, we're moving left. If it's subtracting a number, we're moving right. And let's apply this. Again, same parent on these two. So the 0, 0. So we're still comparing it to the x squared. So 0, 0, negative 1, 1, 1, 1. Now I'm going to take these 3 points and I'm going to move them all 2 units to the left, backwards of what you would think. So move them to left, to left, to left, and then make your new U. This was the original. It sort of went on top, but that's fine. The next one, we're going to move it because it's subtracting 2. We're going to move it 2 units to the right. It's in the parentheses. So this will be 2 to the right. Same parent, it's still the x squared function. So 0, 0, negative 1, positive 1. And now take each of the points, move them 2 over to the right. And then make your new U. Again, you're memorizing that a parabola takes on a U shape. Now we're going to switch our function and we're going to do the x cubed function for the next 2 examples. Remember, the x cubed has that little wiggle to it. So for the x cubed graph, again, I'm going to use the same order pairs to plug in, negative 1, 0, and 1. And then I'm plugging them into x to the 3rd power. Negative 1 to the 3rd power is negative 1. This is still the same. So the negative 1 order pair, instead of being positive 1, it's negative 1. So let me go ahead and add these 3 for the parent. So here, here, and here. Do not connect them and make it a diagonal line. Remember, it's got a wiggle to it. So it goes up like this and then down like this. That's the shape that the x cubed graph takes on. And again, you need to memorize it. The 1 is not in a grouping symbol. So this tells me I'm going to be shifting all 3 of my points 1 unit down. So when it's up and down, it's what you think, whatever sign is there. Pretty good? Good? So now I'm going to shift them all 1 down. So this one will go down 1, the 0, 0 goes down 1, and then this one goes down 1. Connect your points, add the wiggle to it, and there's the shifted graph of 1 unit down. The next one has two things going on, yes. They do the letters. So let's say you didn't have colors. Then what they would do is they would say the black one, they could say that this is the f of x function, and then they would put that no, I'm sorry, that's the g of x. I'm doing this backwards. This one, the black one, the original parent is the g of x. That's what I had called it. So g of x equals just the plain x cubed. And then the new one, the red, was the f of x. So instead of having to write the whole equation, let's say you didn't have colors, then you would label and say this one's the f function, this is the g function. And that's why they're introducing different letters. The next one has a double shift. So I'm going to use 3 different colors. If you want to do the shift from parent to the final shift, that's fine. But notice this one, I'm going to be shifting it 1 unit up and 2 units to the left. Again, it's still the x cubed function. So 0, 0, 1, 1, negative 1, negative 1, negative 1. So this is the original. So I'm going to do the first shift 2 to the left. This will be the first shift I make. I'm going to do it in 2 steps. So take all 3 points, move them 2 to the left. Connect it, make your wiggle. Now I'm going to take those 3 blue points and I'm going to move them all up 1. And this will be the final. So 1 up, 1 up, 1 up. Make your wiggle and you're done. If you wanted to just do it 2 left and 1 up from the black to the blue or black to the red and do it in 1 graph, that's fine. And it's still the x cubed graph. In the parentheses, this is going to tell me that I'm moving it 3 units right. And the +1 tells me, or +2 tells me 2 up. So I'm going to graph my parent. Again, my parent is the x cubed graph. So I'm going to graph the -1, -1, 0, 0, 1, 1. Add the little wiggle. And now I'm going to move first the red, or sorry, first blue. First I'm going to go 3 right. And then second, I'll go 2 up. And then this will be the final. Again, if you'd rather go 2 up first and then 3 right, it doesn't really matter. So take the 3 points, move them 3 to the right. 1, 2, 3. 1, 2, 3. You can add your wiggle. And now the red, take all of them and move them 2 units up. 1, 2, 1, 2, 1, 2. Here's the wiggle. So the red is the final graph. After you've shifted it 3 units right and 2 units up. Now we're going to try a square root function. So for number 8, now if you remember from yesterday, when I did the square root function, remember we didn't want any negative numbers, we don't want any imaginary. So I'll plug in this time 0 and 1, and then I'm also going to plug in the next perfect square after 1, which is 4. Because when I square root 0, I get 0. The square root of 1 is 1. The square root of 4 is 2. So now I'm going to graph these 3 order pairs, 0, 0, 1, 1, 4, 2. So 0, 0, 1, 1, 4, 2. You can choose whatever you want. I'm just trying to plug in as, low as possible. So now I'm going to look. Under the radical, and remember, or in grouping symbols, this is the shift left and right, backwards of what you would think. So this is going to be a shift 3 units to the right. And this one's going to be 2 up. The order you do them doesn't matter. I'll go ahead and shift the 3 points 3 to the right first. So I'll shift those in blue. 1, 2, 3. I could zoom in here. Just count the little boxes. 1, 2, 3. 1, 2, 3. And it's right at the edge. Connect your points. That one, I wonder why it's so doubled. Let me erase. One, 2, 3, and then 1, 2, 3, and connect. So this is the first shift of 3 to the right. So first I'm doing the right. Second, I'm going to do the up. So 2 up. So now take each of the blue ones, go up 2, and then connect them with the same shape that the parent takes on. Yes. Oops. On the next slide, when we're talking the reflections, I know this pink bracket here is hard to see, but the first 4 functions here, these are all reflections or flips across the x-axis. The last one is a flip or a reflection across y. So when the negative sign is in the grouping symbol or under the radical, it's across y. But if it's outside, in front of the function, or in front of the square root, then it's a flip across x. So you're just going to memorize where all of these things are located, and then that's how you're going to know how to move the graph. So let's try some reflections. So let's identify what's going on here. So this is outside of it. It's not in a grouping symbol. So this negative sign is going to tell me this is going to be a reflection across the x-axis. And then the +2, this is up 2. So if you recall back from Algebra 1, when you graphed parabolas, when the number in front of x squared was positive, it was a happy parabola, it was smiling, it looked like a smiley face. But if it's a negative number, a negative person, they frown. So it's just reflecting it and flipping it. So let's go ahead and graph the original parabola, the x squared. So I'm going to graph first this. So 0, 0, -1, +1. And remember, it looks like this. I'm going to do the reflection first. So I'm going to flip it. So I just reflected first. So reflect first. It doesn't matter what you do first. And then second, I'm now going to take that reflected image and I'm going to move it up 2. I'm keeping it facing down. I'm just moving the points up 2. And there's your reflected and shifted graph. The blue one is the final. So when it's under the square root or in a parentheses, this negative sign underneath tells me that this is a reflection across the y-axis. So I'm going to graph my original, the 0, 0, the 1, 1, the 4, 2. And now I'm going to reflect it across y. So put it over here and over here. So we flipped it across the y-axis. The last transformation is when there's a number in front of your function. When this number is greater than 1, then this is going to be a vertical stretch. When this number is less than 1, meaning it's a fraction, then it's going to be a vertical shrink. So what you're going to do is think of them as taking the ends of your graph and stretching it, and it's going to make it become skinnier. But when you shrink it, it's like they're pushing it down and making it shorter and flatter. Now, when you do the vertical stretch and shrink, when there's a number in front, I would just do a table of values. So, and you can use your same numbers. Plug in -1, 0, and 1, and get the new order pairs. So plug in -1, you square it, and it becomes 2. Plug in 0 and square it, this becomes 0. Plug in 1 and square it, times it by 2, and it's 2. So the new order pairs are going to be -1, 2, 0, 0, 1, 2. What you're going to see is your graph is going to go up faster. Normally, the parent for the x squared, remember, was -1, +1, 0, 0, and 1, 1. You see how it gets up faster because it's going to jump to the 2. So let me go ahead and put in the parent just to compare. So here's the parent again. But then the new one, instead of going to 1 first, it goes up to the 2. So this one's getting skinnier because it goes up faster. Then this one, it's a little bit wider. So for the vertical stretch and shrink, you're just going to plug in some values. Yes? Reflection, because it's got a negative sign outside. So this is a reflection across the x-axis. So again, let's graph the original parent. And then this time we're going to reflect it across x. So we'll go down here and go down here to 4, 2. And for the last one, we're just going to do a table. Plug in our x's, -1, 0, 1. Plug it into 1/2 times x squared. So 1/2 times -1 squared is just 1/2. 1/2 times 0 squared is 0. And 1/2 times 1 squared is just 1/2. So normally it would look like this. But now what's happening is it's getting fatter. So it's only hitting it at 1/2. So it's getting mushed down and they're shrinking it. So for this stretch and this shrink, just plug in the -1, 0, and 1. If it's a number bigger than 1, it goes up faster. That's it.